Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back to another video. I'm not going to film this again because I'm tired and I want to get this over and done with. What time is it right now? It is 5:35. That's how I opened my watch, by the way, because I haven't turned on the turn to switch on feature because I don't want it turning on randomly at all times. I'm here with Daniel because he told me to go to Portland building. I would have gone to a different building to see if there was a whiteboard with a room. But because there's no whiteboards.
Maghrib is in 20 minutes, guys. I had reason.
Oh my dear. That means I have to like speed run this video, which is absolutely insane. So I spent like half an hour. You spent half an hour talking to some Indonesian guys because you can just tell when someone is Indonesian, right? Okay, as I say this as an Indonesian, you guys probably can't tell. So I asked him, where are you guys from? Indonesia. Oh, I freaked out. We had more than half an hour just speaking together. Oh my god, it was such a nice conversation. But this is supposed to be a schoolwork maths getting cooked with A-levels video, so let's get started with that. What was my first lesson? My first lesson was, oh yeah, sorry for the LGBTQ flags. I can't do anything about them, they're here. They're going to be in the background of the video, sadly. Okay, yeah, time to check what my actual... I have so much to do, it's absolutely insane. Also, I'm hungry too. Guys, you should meet Indonesians if you can. They're such cool people. Where did all my tabs go? My tabs disappeared. He said he was covering up the flags. Okay, I'm gonna check my timetable because I don't even remember what lessons I had today. So, I had physics first. I had physics first. Let me just grab a chair real quick. Okay, physics. It was physics with my classical physics teacher. I need to position my phone correctly. Wait a second. Bruh. Okay, this. I need to get... you don't have to be here, by the way. No, it's okay. It's okay. You need that. Okay. Hello. Time to get started. So, in classical physics, because we finished gravitational fields... Is that even a thing? Gravitational fields, yes. We finished gravitational fields last week, so we moved on to electric fields. And with this lesson, we went over... So, last lesson we went over Coulomb's law. So, for example, the definitions of permittivity and permeability. Permittivity is when... What's permittivity? It's how well a material is able to transmit an electric field. While permeability is to do with magnetic fields. And you don't need to know the definition of those in A-level, but you need to know that permittivity is for electric fields and permeability is for magnetic fields. And the reason you need to know this is because they're literally right under each other in the formula book, so you need to know this so you don't mix them up. Coulomb's law states that force is proportional to 1 over r squared, and it's proportional to charge 1 times charge 2. Okay. As you can tell, I'm completely confused with these fields and stuff. But I can explain to you some simple things. Firstly, gravitational potential. You can calculate gravitational potential by doing work done over unit mass. Work done over mass. With the units joules per kilogram or joules kilogram minus 1. To define gravitational potential is the energy needed to move a mass from an infinite distance to a point in the gravitational field, while electric potential is the energy required to move a unit charge from an infinite distance to a point in the electric field. Let me just check that. His work don't really understand. Okay. Okay. And then you have the field strength equation, which is what is the field strength? E equals F over Q. Okay, and then in the next part of the lesson, we had parallel charges, parallel like bars of opposing charge. So we have positive charged bar at the top, a negative charged bar at the bottom, and in the middle, you'll see that they form uniform field lines, electric field lines, while at the edges, they bulge out. And that's because there isn't a force on this side pushing it, like keeping it in parallel lines. And that is that. And then we just worked out the force of repulsion and the force of gravity using the equation Q1, Q2 over 4 pi. I forgot the permittivity thing. Oh, I have it here. Permittivity of free space. So in that equation, the constant is Q1, Q2 over 4 pi permittivity of free space. And that is the constant in the equation. Danielle is doing whatever behind me, behind the camera.
I'm watching your videos.
Why?
They're really nice.
Okay, nice voice track.
Voice track.
Yeah, so we got some example questions. For example, two electrons in a vacuum. You need to work out the force of repulsion between them. You have the charge of the electron, which is 1.67 times 10 to the minus 27. That's the mass of a proton. It's 1.6 times 10 to the power of minus 19. So you multiply that by itself, because it's two electrons, they have the same charge, over 4 pi multiplied by the permittivity of free space multiplied by r squared, which in this case was 1 meter. That gives you the force of repulsion. And then to work out the force of gravitational attraction, so the force that's pulling them in together because of the gravitational fields of both electrons. And to work out that force, you do G, which is big G, capital G, for the gravitational constant, multiplied by M1, M2. M1 and M2 are just the mass of the electrons. And then that's all over r squared, which is 1 meter. And you'll find that the force of the gravitational attraction is a lot less than the force of repulsion. Oh, I forgot to flip the camera again. Whatever. So you'll see that the force of gravitational attraction, that one at the top there, is a lot smaller than the force from the electric field, force of repulsion. And that is because they're such small masses. But when you're talking about our planet and our own bodies, the planet has such a significant mass that it creates quite a heavy gravitational attraction on our object. But we're relatively neutral charges, which is why we experience gravitational attraction, but not electric. We don't experience the electric field of the Earth. We did a question at the end. If...
All our kids?
Yeah.
Are we students?
No.
That's the question. You're definitely not a student. You a student?
No, you asked me this question earlier.
Hey?
You asked me this question earlier.
Did I?
A few months ago, yeah.
Months ago?
Yes.
Was you a student?
No.
You are. You know.
Okay, anyways. I get that question a lot. So, if you take away 1% of these, if you count all the electrons in your body and you take away 1% of these electrons, you'll be left with the equivalent energy of 3.2 times 10 to the power of 7 joules, considering your 60 considering your 100% water and your 60 kilograms. Now, if you calculated the force between two students where 1% of the electrons were just ripped away, then you would have a force of 9.2 times 10 to the power of 24 newtons between you, which is why even 1% difference between the amount of electrons you normally have and the amount of electrons you could have if they were stripped away, 1% of them, you would have an insane force between you. And that is why we're relatively neutral. So that's what that question was going through. That's my first lesson. And then we had further maths next, which was differentiation. We went through a question. Pure maths. Oh, we didn't actually go through any questions because we were going through our chi-squared tests and there was a lot of things that we got wrong, so we just spent a lesson going over that. So I can't really go through much of that with you. But I can go through the do now question that was given. So liquid is pouring into a container at a constant rate of 20 centimeters cubed per second. So that means the rate of liquid flowing into the container is 20. And how do you get the rate of something? The rate of something is just the first derivative, which is dV over dt equals 20. And that's the volume going inside the container. But it's also leaking out at a rate proportional to the volume of the liquid already in the container, which just means dV out over dt is proportional, so the proportionality symbol, to the volume already inside the container, which is V. So you can represent dV out over dt is equal to minus kV. Why the minus and why the k? K is the constant of proportionality, so if you turn a proportionality relationship to an equation, to an equal sign, then you have kV, and the minus is because the volume is leaking out. So in reality, so you have dV in over dt is equal to 20, and dV out over dt equals minus kV. So you add them together, and you get dV over dt is 20 minus kV, and that's how you get this equation here. And that's 2 marks.
Alex, I'm going to get to the playroom now, inshallah.
Inshallah. Do you know when the prayer is?
It's going to be around 6 o'clock.
Okay, inshallah. I'll be there in like 10 minutes, inshallah. Wa alaikum salam wa rahmatullahi wa barakatuh. I will join him soon. Bye-bye. Okay, so that's further maths. And then I had computer science. You know, this worksheet, we have like, I've 3 pages left to do on it. And it was due in today's lesson. And pretty much no one did it. So our physics teacher was very disappointed. But like, I honestly don't know how we're supposed to have so much time. In this morning's assembly with our head of sixth form, she mentioned that we're supposed to be doing 3 hours of work after school every single day. Is that not insane? Is that not insane? So let's say I get home at 4 p.m. because school finishes at 3. That means I'm working until 7. So we're working essentially like more than 12 hours every single day. And she says she doesn't want a room full of burnt out students. I'm not sure how that's going to work exactly, but oh well. That's A levels, I guess. So we have computer science now. In computer science, we carried on with the regex, I believe. No. We did Backus-Naur notation. So Backus-Naur notation is a mathematical notation used to formally describe the syntax of a language. Let's go to it now. So for example, you can use English to say, a man watched a cow on a hill with a telescope. That could mean That can mean several different things. The man could be seeing the cow on the hill using a telescope. The man could see the cow on the hill standing next to a telescope. Or the man could physically saw the cow using a telescope. And there's other interpretations of that context. That's why we can't use English to describe, like, unambiguously the syntax of a programming language. So I'm opening my class notebook right now. I'm not sure why I was so much more fluent yesterday when speaking, but now I just feel it's very hard to speak in front of the camera. Anyways, abstraction is ignoring parts of a problem to make it easier to understand and solve, and then decomposition is breaking a complex problem into smaller, solvable problems. And types of abstraction include information hiding, data abstraction, functional abstraction, procedural abstraction, and probably a few others. Oh, Backus-Naur notation. Okay, this is exciting. So in Backus-Naur notation, you have these. That's inverted. Anyways, you have a variable name enclosed in, I don't know what to call this. I'm going to call them brackets for now. Angled brackets. Yeah, so you have variable names enclosed in angled brackets. And that just defines, just call that an assignment operator. This defines a rule in Backus-Naur notation. So, for example, this line, or this digit, states that for a digit to be a digit, it has to be any one of these values. And the pipe symbol is just an OR operator, as you probably already know. And this displays recursion. So the integer can either be a digit on its own, or it can be a digit and, wait, what does that say? A digit and an integer, which is itself. So it's literally being a recursive loop. And why is that? It's because if we want to have multiple characters, or we want integer to have a variable length, we need to be able to assign it one digit, or one digit and itself. And when it calls itself, it can either add one more digit, or it can add one more digit and another integer, which can be 0, which can be 1, or infinitely many digits. Now, I think I explained that wrong, which is quite sad, to be honest. But that is essentially what it is. And you can have a for loop that is syntactically correct, but when you compile it, it will cause a compile error. And why is that? It's because even though your for loop is syntactically correct, the ranges of your for loop may be wrong. So for example, if you want to go 1 to 10, that's correct. But if you want to go 10 to 1, that could cause a compilation error. And you could also put like integers out of this wrong type or stuff like that. And that was pretty much the whole lesson. It was quite simple. Yeah. That was computer science. And then our final lesson was maths, which was series. And that was also quite simple. But with series, we were doing summation. Okay, I have 5 minutes, and then I've got to speedrun disappear. Okay, this is a fun one. So, these are worded problems to do with series. Bruce starts a new company. In year 1, his profits will be 20,000. So A is 20,000, but we don't know if it's an arithmetic or a geometric series. Then it mentions he predicts his profits to increase by 5,000 each year. And that's a constant fixed rate of 5,000 added on every single year. So it starts 20,000, 25,000, 30,000, and so on. So it's an arithmetic series where a equals 20,000 and the difference is 5,000. So if you wanted to find the profit in the first 3 years, it would be 20,000, 25,000, 30,000. And how would you actually represent that using summation? So S3, the summation of the first 3 terms of the sequence, will be n over 2, where n is the number of terms in the sequence. So 3 over 2, and then brackets a plus l. A is the first term in the sequence, L is the last term in the sequence. So A would be 20,000, L would be 30,000. Add them together, 50,000 times 1.5 is 75,000 in the first 3 years. Yeah. And that's essentially worded questions with series. And with summation, also, by the way, I'm going to end the video soon because I need to pray Maghrib. And you shouldn't delay your prayers. Do not take me as an example of delaying your prayers. Maghrib is in a few minutes, so I'm gonna run there, inshallah. I want to tell you one more thing. If you fold a piece of A4 paper, which is 0.5 millimeters thick, so literally the thickness of a piece of paper, if you fold it 20 times, it will be 5 kilometers tall. Isn't that crazy? Just 20 times folding a piece of paper, which is literally just, you can barely, it's like the width of a strand of hair. Will turn into 5 kilometers if you fold it 20 times. Subhanallah. Anyways, that's the power of geometric sequences. I am going to go. It's a long day, man. It's a long day. I have like 1,000 words to write today or tomorrow, which I'm probably not going to get done. It's a long day, man. Long day. Long day. I don't know how other people do it. I don't know. Yeah, so I have the honours and activities still left to do. I've done most of it. I just need to fill out the descriptions for each of them. And then I need to write my Common App essay as well as my supplemental essay for my early decision in university. Long day, guys, long day. And then, yeah, just managing the iPhones and everything. But inshallah, all will go well. All will go well. Assalamu alaikum wa rahmatullahi wa barakatuh. I wish you a beautiful day, and inshallah, all your efforts will come to fruition. I don't even, I'm too tired, man. In the dunya and the akhirah. Assalamu alaikum.